All right, here's our 6.4 part 2 video. Today we're going to talk about new factoring patterns. So you don't have to write this first part about old factoring patterns up here, but I just want us to look through and think about what are some of these patterns. So just recognize this first one is shortcut, something that you should be able to do without having to show much work. This one is where you all are either going to do AC, box, or bottoms up. And that is because you have a 2 here at the front. Right here, some of you crossed this when you came to your homework in class today, but on a question like this, we would just do GCF. So remember, we'd look and see what can we take out of both of those. And I'm just giving you this side note. If you could take something out, it would be a 3x to the third. And when you divide that, that would give you x minus 5. And that's the end of that factoring because you can't really break that apart anymore. And then our last one was a pattern that we briefly touched on at the end of class, but I think you all are okay. It's called difference of squares. Difference because it's subtraction here in the middle, and squares because both of these numbers need to be perfect squares. So on something like that, if we broke it apart, we'd first think, how do we break x squared apart? Well, we do that by making x and x. And then to break -9 apart, we're going to have +3 and -3. Notice that those have to be opposites. And shout out to Kaylee. She actually gave us a good word that these are called, because they look the same but they're opposite sides, they're called conjugates. You may want to write that word down just in case we see it again later on. So this is really the most important part of what you want to write down, is this new pattern that we're going to learn down today, and it is called sum and difference of cubes. So two things. First of all, now we're going to include sum, which means addition is an option, and cubes are our cubed numbers. So I'm going to take a second to write some of those off to the side, and those numbers are going to be 1, 8, 27, 64, 125, 216, and we can keep going. Those are just some that you should recognize, but I'll show you tomorrow how to use your calculator to check if something is a perfect cube. So the pattern that we want to recognize, I'll do sums first. So it's going to be, this is the pattern, a cubed plus b cubed, and that should not be in parentheses, is going to factor to give me the first parenthesis is going to be just taking the cube roots, so a plus b. The second parenthesis gets a little longer, so we take the first number and square it. So I'm going to write a squared. Then we take the last number and square it. So at the end, I'm going to have b squared. And in the middle here, we have these two numbers multiplied together, but the sign is changed. So if you multiply, what I mean by these two numbers, if you multiply a and b, that gives you ab, but I'm going to change the sign, so it should say minus ab. All right, so one more time. I took the cube root of a cubed and got a, the cube root of b cubed and got b, square the first, square the last, multiply, and change the sign. The next example is for difference of squares. So this is very similar. This time, notice it's going to be a minus b, square the first, square the last, multiply, and change signs. This may make a little bit more sense to you when we do an example, so let's take a second to do that now. All right, so here's my first example. Remember, the first step that I always want to do on any problem is take out my GCF. And you'll notice here that we can take a 5 and an x out. So my GCF is 5x, which is going to give me this new problem of 8x to the third plus 1. Now notice I've got some perfect squares here. 8 is a perfect, not square, I'm sorry, cube. This is 2 to the third power. X cubed, obviously a perfect cube because it has a 3 as an exponent. 1 is also a perfect cube. That's 1 to the third power. So let's practice that pattern. All right, the cube root of 8x to the third is 2x. the cube root of positive 1 is plus 1. That first parenthesis you always have to do on your own. The next one, you're going to refer back to this previous parenthesis. So I'm going to take this and square it. That's going to give me 4x squared. Take the last number and square it. That'll give me plus 1. And now I'm going to multiply these two things and change the sign. If I multiply, that gives me 2x. So in my parentheses, I'm going to write negative 2x. The only thing that I'm missing from this as my final answer is my GCF. So I want to bring my GCF down, and my final answer is going to be 5x, 2x plus 1, 4x squared minus 2x plus 1. That is my factored form. It looks like a whole lot, but it's the shortcut and much, much simpler than any other factoring method to break down my original equation. All right, let's try another one. This time, my problem, so I still want to think, does it have a GCF? There's nothing I can take out of all three of those, so my GCF is just 1. If you want to write that down, some of you liked writing that down last year just so that you were in the habit of doing so, which is fine. Now you've got 4 terms, which should make you think, so you may want to make a little note. 4 terms should make you think grouping. So that's how we're going to start this problem. So I'm going to go ahead and group, and I want to think to myself, I'm going to move my GCF out of the way. I want to think to myself, what can I take out? So x to the third. On the second set, the only thing you can take out of an x and a 1 is just 1. So remembering my pattern from today, that's going to be x to the third, x plus 1, plus 1, x plus 1. Remember, I want my parentheses to match. So my next step is going to be the matching parenthesis, and then the GCFs that I had in the front. That's these two numbers out here. Now, some of you may say, oh, well, I'm done. But today we're learning that this portion right here, the second parenthesis, is sum of cubes. It is a perfect cube sum, so it's something that we can break apart even further. So I'm going to take a second to work that part out. So the cube root of x to the third is just x. The cube root of 1 is 1, so my first parenthesis is x plus 1. My second set of parentheses, remember I take the first and square it, take the last and square it, multiply together, and change the sign. So it's going to be minus x, or you can put minus 1x in the middle if you want to. All right, so think about this second set of parentheses split apart to give me these now. So my final answer, I'll write in red, my final answer here is going to be x plus 1 from this factor, and then x plus 1 from that factor, and x squared minus x plus 1. And you might recognize that there's actually one more thing that we can do. Because these factors are doubled, we could even write that in a simpler way and say that this is x plus 1 squared, x squared minus x plus 1. One other question I think you might have at this point is, why do we not keep going here? Well, the reason is because that part will never factor. And when you have perfect cubes, just know the second part, even though it looks like it could be AC method or a shortcut, it will never factor. You're never going to be able to come up with numbers that work. So that's why we're just going to leave it like it is and move on. All right, so that's all I've got for you tonight. We will practice one of these tomorrow, and then in class, we're really going to spend most of our time kind of putting all this stuff together and getting really, really good at factoring before we use it to do one more thing on Wednesday. Have a good night.